This is graph of cosine. Let's make that thing bigger. So what you can do with the title is give the title again and then tell it explicitly what font size you want. Okay. So let's do the title command again. Okay. And what do I do here? Graph of cosine. Font size 16. Okay, so add just one more argument there. And then that's the font size. And now, let's say 16. I don't know what the default is probably 12 or something. I don't know. But you'll see it's going to be much. Let's look at the graph before we issue it. See that? Okay. The top, the title. Now let's do this guy. And you'll see now it's much bigger. See? Graph of cosine function. You can even make it italic. You can make it bold. You can make it red. Okay? Goes on and on. Anything you can think of, MATLAB can do. Okay? Yeah, let me do that now, okay? Now I'm going to get rid of this plot thing over here, so go like that. Start off stretch. Remember when I did plot x, y, MATLAB, the first graph defaults to blue. Suppose I'm going to do it in red, okay? Again, look at the plot command. You have your x versus y. If I stopped over there, it would be the blue plot that we saw before, okay? And now you put comma, and then there's a code for red, which hopefully is R, okay? Now we'll see the cosine graph, just like before, everything bare, but it'll be in red. Okay. What do we do now? Oh, you can do a dash also. Suppose you just want to do a dash. Plot x, y, comma, you actually can combine. Let me just do a dash short by itself. No, I think that's going to be a blue dash. No. It has to be a double. If you do that, it's a default. I need a double dash over there. Sorry. Yeah, if you want to do a dash curve, you put a double dash over there. Okay. See, it dashed it blue. Now, can you dash? Yes.
What happened to the title and the label?
The what?
The title.
Oh, the title. Oh, I closed that window, so I started over from scratch. Yeah, I could have kept that one and then there. Okay, so now we have this. Suppose I want dashed red. Okay. Well, you just follow that dash code. I think this will work by an R. Now it's dashed red.
So if you do the dash and then a new variable in it R,
yeah, that's what we're going to do next.
Still do the same way.
Yeah. Okay. So now let me show you. How do you coplot two things? So we had y is cosine of x, right? Let me plug into z the sine of x. Z is the sine of x. So now we're going to plot the sine and the cosine, okay, together, okay? Okay? So, plot, okay, if I do x comma y, okay, what was that? That was basically the cosine graph first, and then you want to plot again x versus, because in general these may be different dimensions, right? X and y have to be the same dimensions, but maybe the next xy pair is a different dimension. But we'll do x again, and then z. Okay? Now, in this case, we know because the first one is the cosine graph, which one to look for, right? The blue is the cosine, and this thing is the sine. Now, I'm doing sines and cosines, but in a report that you're doing some work, okay, you're plotting things, you want to be able to tell the person what graph is what, you know? Okay? So there's a very nice thing that MATLAB has built in, I think it's called Legend, okay? And what it does, see a default, okay? MATLAB's default is the first curve is blue, the next one is red, and the next one, you just have to experiment, I don't know what it is. It goes through a whole spectrum, okay? But what you'd like to do is put a little legend over there. I'm gonna make something very simple, and I'm gonna put legend, and MATLAB, of course, remembers the order that it plotted, right? So if you remember that your first one was the cosine, and the next one was the sine, just put in a legend command with those labels, okay? So let's do that. Again, don't close this, because we want to operate on that guy. So we do legend, okay? So legend, what's the syntax for legend? Okay, yeah. Quote, okay? This is help that's MATLAB is giving you, okay? Now comes the first guy, I'll say cos, okay? And then comma sine, right? And something very interesting will happen. Okay, let's look at it. You notice what we got over here. We got this, and it's pretty small, okay? But you can make it bigger. You can adjust the colors and everything. But what happened was very nice. MATLAB was very smart. It said, okay, I knew that I plotted the first guy, which is a cosine in blue. So when you put cos for your first legend, it shows the blue, and then sine would be the red. Obviously, you can use this, to clearly identify what you're plotting when you have many graphs on one set of axes. Okay. So that's a good thing to know. We have any questions so far on any of this stuff? I think it's pretty straightforward. I'm going rapidly, but again, because most of this stuff, all the stuff is in the documentation. Okay. Let's go on now to some program scripts. Okay? Programs and scripts, rather. Okay. I have them. I have to tell you the difference between the two. Okay? A script, this is just MATLAB's, notation. A script is just a file that contains a sequence of MATLAB commands. Okay? It's not like a function where you have an input and an output. Okay? So if I'm doing something basically, and I want to do that over and over again, but not like a function, I can just save all the commands into a file, and MATLAB will just execute that file, so I don't have to type it in every time, over and over again. And I have some, hopefully I have some over here. What's the first one I want to show you? A plot vessel. Okay, here's one. Let's look at that one. Plot vessel, okay? And if you want to look at something, let me just open that up for you. Open. Okay, I'm now opening up this thing called plot vessel. Okay? MATLAB, when you want to create a file, you go to this thing over here called new. Okay? See, and it gives you a choice, a script or a function. Okay? When I did that, I just did script. But let's get rid of that because. Okay, let me go back to plot vessel. It's already been created for you. Okay, let's look at this thing and see what that does it do. Okay, first thing I do is I create a vector x that goes from 0 to 10 steps of 0.1. Because we know it's not going to hit 10. Oh, we'll hit 10 in this case. Okay. Okay, so x goes 0 to 10. And notice the semicolon at the end, because I'm just interested in the plot over here. I don't want to see x in all these intermediate values. Okay, so I terminate it. Then I say plot x versus Bessel J of 0x. Okay, this is a special function of mathematical physics that comes up a lot when you do things with cylindrical symmetry. For example, vibration of a circular drum head or heat conduction in a cylinder. Okay, these are special functions of mathematical physics that MATLAB knows. I could have put there plot x sine x. Okay, I just wanted to be fancy and do something that looked a little different. Okay, okay, there's the plot. Okay, I put an x label x, and I put a title on there. Let's look at the title. Bessel function of the first kind of order 0, because that's what it is. And I make font size 18. Okay, so it'll be a pretty big title on there. Okay? Now, when I run this script, it's exactly the same as if I went into the command window and issued these commands in that sequence. Okay? So it's saved over there, so we know what it does. Let's just close that. Okay, I want to run this thing. Okay. I have two ways I can do it. Let me show you one way. One way you can do it, if you like at a workstation and you don't have this nice interface, you may have to do it this way. Suppose I have a script that I want to, in my, you have to be in the right directory, obviously, also. So I'm in a directory where I've got plot vessel, and I want to just execute that script. All I do is I put the name in there. Plot, V-E-S-S-E-L. Now, you'll notice, if you look carefully, it's the name of the file is plotVessel.m. Every file in MATLAB has a .m suffix on it. Okay? Don't put plotVessel.m. You just put down the name, plotVessel. Okay? When MATLAB sees that, it goes through a whole things that you don't have to worry about, but what it's going to do is say, well, do I have anything called plotVessel? Do I have some type of command there? It goes through all its libraries. There's a default of how it searches. It says, I got nothing called plotVessel. Then it'll go to your directory and see if there's a plot vessel. It sees it, and it'll just execute that script. Yeah, I spelled it wrong. It's nice how it suggests that, isn't it? Yes, okay. There it is, see? Bessel function of the first kind of order 0, and that's exactly what it looks like, okay? And I've got my axes. Now let me show you another way if you have like a, on your laptop or on your workstation at home, okay? I can do this also. I'm going into my folder over here, you see, right? I'm right-clicking, and there's a choice here, okay? I can open, just hit run. Does the same thing, okay? I just showed you both because if you're working some like Unix workstations, they don't have this thing over here again. You just have to put plot Bessel. Okay. Okay, so that's one. Plot piecewise. Okay, this is a good one. Let me look at this one. Okay, let's open it up and what it does. Okay, a piecewise defined function, and this will show some other MATLAB constructs. Okay, let me just put it on the board over here, and then we'll explain what I've got. Okay, what do I got over here? X is x squared. Okay, I'm going to plot the following. Here's x. Here's my y-axis. Do this. It's a parabola. And just go straight. So, I want to plot y equals x squared if 0 is less than x is less than a half. And y equals the value, which is 0.25, right? If, where am I going? A half less than x less than 1. Okay, so this is x equal to 1. This is x equal to 0.5. Okay? So we can define a piecewise function, right? The function f of x is the parabola x squared between 0 and a half. After half, it goes like that, okay? Now, something like this, of course, it's not like sine or cosine. It's not built in. You have to program that, okay? So let's see how we would program a piecewise function like this, okay? This may be a better way to do it, okay? What happens is that anyone who's experienced MATLAB program knows when you do these so-called for loops, anything that's, the less vectorized it is, the less efficient it is, okay? Okay. So if you were to time, for example, if I had a vector of 1,000 and I plug x in there and I want cosine of x, okay? If you did cos x, that's the fastest thing you could do. If you do cos x of I equals 1 to 1,000, it's going to take much longer to do. And you can actually time it to see that. Yeah.
Did you mean to write x's between 0 and 1/2? Because does the code do that? Because the plot is between -1 and 1.
Oh.
Right?
Okay.
So
Oh, yeah. Okay. Yeah, let me see what I have over here. Okay. So if x is less than a half, you're right. So it would be the parabola over here. Thank you. Yeah, I didn't look at the code carefully. -1, right? Let's go through the code, and maybe I'm still wrong. I just have to look at the code carefully. Okay. So we take a vector x that goes from -1 to +1. So on the x-axis, -1 to +1. Okay, and now, basically, this is what's called a for loop. It's going to go for every element of x, okay? Okay, we could look and see what the elements of x are. Well, you know what it is, right? It's -1, and then what's -1 plus 0.01 minus point, do the arithmetic. Okay, you know what it is, okay. You get this vector x equals -1 plus 1 plus 0.01. Okay, and this thing, let's look at some new things here. This thing called length of x. You see, I'm being lazy over here, and I can figure out what the length of x is, but to make it general, suppose I want to change this thing. I want to go from -8 to 1 steps of a different, okay? Whatever it's going to do, once that command on the first line, x equals, is executed, the size of x is determined. MATLAB is going to compute it, okay? And therefore, this thing called length of x tells you exactly how many elements there are in any vector, okay? So, how many pieces, how many points I'm going to go through, however big x is. So now, I equals 1 to length of x. Now it goes into the ith element of x, and it just tests. If it's less than a half, okay, yeah, if it's less than a half, yeah, it's x squared. So certainly this point will go x squared, all the way to a half, right? And then this thing called else. And notice basically I have a thing called f over here, that's what I'm putting the function in. So it's creating a vector f the same size of x. So if the value of x is less than a half, it just squares that value, stores it into the f vector, else it puts it at 0.25. So we know exactly when it reaches 0.5, it'll be continuous, and it'll just go like that. Okay? Anything else I want to talk about over here? Interesting, they have little things. You notice basically, I don't know if you can see it over there, you notice there's a little orange swiggle over here? And that's usually like a syntax. Either it's an error or it tells you something that maybe it's not efficient. The variable f appears to change size every loop iteration within a script, consider pre-allocating for speed. Okay. And this is, if you had a really big one, array, you would do that, okay? Because what's happening over here is that it goes to the loop the first term I equals to 1, gets x1, and computes f1. So now MATLAB thinks f of 1 is just a 1 by 1, right? Then it comes a second time, it's just f2, it has to pre-allocate now size and make it a 2 vector, then a 3 vector, okay? That takes time. For this program, it's trivial, so I'm not going to bother to do it. But if you had something that went through like, 50,000 values, okay, that would be very inefficient because it would have to build up the vector and augment the size every time. So what MATLAB is telling me is that the best thing to do is that before you go into the loop, just allocate size for f and then let it go through. Okay? So, and it's interesting, you see that over here, and even I think on the side you get the same type of thing. There's something over there. Yeah, same thing. Okay? So you see these little things here, or swiggle onto something, you should look at it because it usually doesn't mean that it's a syntax error necessarily, but many times they'll give you something that's more efficient way of doing it. Okay. So everybody understand the code? You got that for loop. I spoke about these end things, okay? Every for loop has to terminate with an end. And what's nice about it is that MATLAB, I didn't do these indentations, I just entered the commands. And MATLAB knew that this for and end is one block, okay? And an if also has its own end statement. Now this is a very simple, this is the simplest form of an if statement. If this condition holds, do that, else do that. You can have nested things. You can say, if this is true, do that, else if this is true. It's called else if this is true. Else if, and you keep going, and then do else for what's gone. So you can have a lot of if and if else's in here, okay? So you can have many, it's just not just one choice. Do this if this is satisfied, else do that. There could be other tests, okay, that you do also.